Welcome to those of you that are starting to join for today's session. We're going to get started here in about 2 or 3 minutes. So if there's any questions, go ahead and put them in the chat. And like I said, we'll start here in about 3 minutes. Thanks, everybody. Up to all of you that are here for today's session. We're going to get started now. Looks like everybody here is on time, which is great. I guess I'll give everybody another 30 seconds or so, but we're about to start. So hopefully you're in the right place. We're going to be doing search mastery today and going to be together for the next 3 hours. No, let's go ahead and start. We might as well. So wanted to introduce myself first. My name is Josh Broth. I'm the training manager at Sumo Logic. I have one of my peers here assisting today. Odell Gordon's going to be out there. So Odell will be assisting from a chat standpoint. So for today's session, if there's any questions, go ahead and put them in the chat and he'll assist in answering them. And if there's anything we need to bring up to the larger group, we certainly will. So let's go ahead and dive in here. This class is not very slide heavy. You may have been with other in other classes of ours, but this one is much more lab focused. But I do have a couple slides to set the stage. So here's our agenda, starting with the introduction. And as you see, quite quickly, we get onto hands-on lab. So this is the intro right now, and then we'll get into the lab. So we have about, I don't know, 10 or so different labs, and we'll go through those shortly. And then we'll take an exam. So we're set to hang out for the next 3 hours. The first 2 hours are going to be labs. I was going to say slides, there are none. So labs. And then the last hour will be for you guys to take the exam. And we'll talk about the exam a little bit later. Hopefully you've taken one with us before. If you haven't, that's perfectly fine. As a reminder, if you have taken an exam with us before or haven't, we're still offering our Uber Eats voucher program. So all you have to do is take the exam today, send the certificate into our email, which is going to be training-promotions@sumologic.com. And I'll display this email address later. And send us an email with your job title and we'll send you a $15 Uber Eats voucher. So a great way for you to get a free meal from us, which normally we would provide when we did these sessions in person. But since we can't, we still want to give you a little gift, I guess you could say. So I'll remind you about this promotion because it's an easy way for you to get lunch. All right. We're really going to kind of dive in pretty quickly. Sumo Logic, you may be aware of, or hopefully you are, you're here. And just as a reminder, Sumo Logic can help you with a lot of different areas and aspects of your organization. Up on the top of the screen, we see some dashboard panels that we or somebody has created, which shows us various aspects where Sumo can help with operational intelligence, security intelligence, business intelligence, really being able to understand what's going on with your systems, your environment. Basically, you're going to take all that data all around the world, wherever that data is from, and bring it into Sumo Logic. And then once the data is in Sumo Logic, then you can start to take advantage of our analytics. So using things like advanced analytics, and we'll look at some of those today, you have the ability to utilize APIs, machine learning, The environments are all scalable and elastic, multi-tenancy, so able to grow with you as you need. And then fortunately, everybody can benefit from Sumo Logic. So all your people can use these tools or this tool and get value from it. So it's really the genesis of this slide. Next slide, pretty quick as well. This slide of data flow for Sumo Logic, you probably saw if you took our fundamentals class or really any of our classes. I like this slide, so it features in many of them because it describes the Sumo Logic data flow pretty simply, and it also describes what we're going to be doing today. Step one, which we're not going to be doing today, is collection. Data is out there in the world. It needs to be brought into Sumo Logic. How that happens is through collection. If you're interested in collection, our administrative course or administration course is the way to go, and that goes through collection quite thoroughly. Now, after step one, you have your data in Sumo Logic, however it got there, but it was collected. Step two is where we're going to focus on today, which is searching and analyzing your data. So how do you take all these log messages, this data, as we'll see in a few moments, and start to slice and dice it to actually utilize it and understand it and get some value from it? And that's where the search language is going to help. It's going to be the key to doing all that. Using operators that we'll start to use shortly to slice and dice your data, presenting it in charts to possibly better understand it. And then the third step is that visualizing and monitoring, taking that data that you now sort of understand and possibly presenting it in different ways, a dashboard. So somebody can just look at graphs and colors and start to get a feel if things are going well or not. Alerts, getting an email or some sort of Slack notification, letting you know things are going well or not. And that's where step three comes in. But step two is really the focus for today. So how do we take the data and analyze it? What, how does the query language work? Well, that's what we're all about. All right. One last slide. Sorry, jumpy mouse. One last slide here related to metadata, because we will be using metadata today. We use metadata in most of our classes. And what is metadata? What metadata is, and it's not primarily a Sumo Logic thing. We use it, but we invent metadata. But we use it as when a log message is collected. So when data is ingested into Sumo Logic, it's going to be tagged. The tag, the metadata tag, is meant to make it easier for you to find your data. It's going to give you or somebody in your organization, depending on who sets up these tags, the ability to start to provide structure to your data. We're going to be using the source category as the primary metadata tag today. It's what we at Sumo primarily encourage to be the main metadata tag. And it's going to be a nice way for you to start to understand your data. So we'll be using those shortly. Hopefully you're familiar with them, but if you aren't before today's class, that's fine. We'll go over source categories pretty quickly. The first thing we cover is getting into the data with the source category. So let's go ahead and jump in. Let's start to do some stuff. So we're going to go ahead and log in together. And the credentials we're going to use are on the screen right now. If you've used credentials with us before, you kind of know the deal. But if you haven't, these are what we're going to use. So you're going to go ahead and log into service.sumologic.com. And I'm going to put these in the chat as well. And the email address is going to be training plus analyst number. And I want you to select a 3-digit number. So maybe you want to be training plus analyst 007, training plus analyst 398246. Pick a 3-digit number, doesn't matter. And we'll use that as the email address. And then the password is going to be Feb 2022 ! So once you get logged in, perfect. You guys are already on it. Please let me know your number. If there's overlap in the numbers, it doesn't matter at all, especially for this class. So that's fine, but it's also just a good indicator that you are logged in. If you can't get logged in, let us know. Odell is hanging out. So if he needs to do something to get you help, just give a shout. If you haven't used these credentials before, these are a training environment, so keep that in mind. Don't put anything proprietary in there. I don't know why you really would. These get cleaned out periodically. It's a training environment you've dealt with on before. Let me go and log in. And while I'm logging in, I'm going to put another link in, this is actually going to be the first link in the chat. And this is going to be a link to our labs, which we're going to use now. So hopefully you see that link in the chat and are logged in. And I'm going to kind of join you here. So let me go ahead and log in. And Feb 2. And then that link I just shared. So I'm going to go ahead and open that up as well. So what I should have, and hopefully you have as well, are 2 tabs, maybe more, but the 2 are really the ones we care about. 1 tab with Sumo Logic, and then 1 tab with our labs. If you need help getting to those, let me know. Hopefully you're there. For the tab with Sumo Logic, I'm assuming everybody's used Sumo Logic before, but that's probably not a good assumption. When you log in, you should be on this page. You might have some tabs showing, and this is just remnants or artifacts of somebody else logging in previously. You're welcome to close them. But ultimately, you should be on this page or this front page, which is our home page. The idea being, like really any other home page, we want to get you up and running as quickly as possible. So you come here, you can access different features within Sumo Logic. We're going to really be focusing on log search today. Actually, that is the only one I think we'll do today. Actually, we might do live tab. And then we see things that you've recently run, recently opened. On the left nav bar is exactly that. It's a nav bar that lets you start to view your things that you've saved, your queries that you've saved, what other people have saved, get into some of the more administrative features. And so what we're going to be doing today is primarily going to a new log search. That's really where we're going to be going most of the day. So what I want you to do is go to a new log search. So on this homepage, you can either go to the log search button, or what I'm going to encourage you to do for today, because we're going to create a lot of new log searches, probably about 15 of them, is using the plus new button. So plus new log search, and now you have your log search. And when we want to do another one, plus new log search, and we start to get our sequentially numbered tabs. And like I said, you're probably going to get up to about 15 or 20 of them by the end of the day. So we have our tab. We can now do a log search. Well, now let's go do a log search and start to understand log searching. So what we're going to do is now use our labs. We're going to go to lab 1. And we're going to go through each of these. So as you see, there's 13 labs. I don't know that we'll do all of them. We'll see how time goes. We might skip 1 or 2. And each lab does have kind of sub labs, if you will. So in this case, we have lab 1, and we have about 7 different steps. So for the naming convention, I'll be saying this is lab 1-1, 1-2, 1-3, and so on and so forth. Now for these labs and these queries, we are not going to be creating queries on our own today. I don't know if that's a disappointment or not. What we're going to be doing is basically copying queries from the system or from the labs. So what we have in each lab is something we're trying to solve for, I guess you could say, and then the query that we use to solve for that. We're going to start very basic, as we should, because we can't start advanced. We need to start someplace. And we're just going to kind of move through these. So once again, any questions, put them in the chat. I'm going to do them on my screen. You'll do them on your lab, in your environment, and we'll learn together. So the first lab, very straightforward, but like I said, we have to start somewhere. So if we want to search for all messages with a source category, and this is might be our first introduction to a source category, but if we want to look for the source category of Labs Apache Access for the last 15 minutes, how do we do that? Well, very simply, we're going to take this line and copy it. Doing my Command C or Control C, depending on OS. Going to paste it in here, and I'm going to click search. Now, by default, last 15 minutes is automatically going to be chosen. That's the default setting for every query. And what we're doing here is we're saying, look for data with the source category of Labs Apache Access. The source category is giving us that metadata, or is metadata, that's providing us information about this data. If I know nothing about Sumo logic, I know nothing about Apache data, and I tell you, or I am using the source category labs Apache access, there's a few things that you can, you know about the data. Even if you don't know about the data, you still kind of know about it. You know, this is lab data. If this had said QA Apache data or dev Apache data or whatever, it would be that type of data. But in this case, it says labs. It's identifying itself as lab versus any other type of data. It's lab Apache data, excuse me. It's not lab O365 data. It's not lab CloudTrail data, which we are going to use later. It's lab Apache data. And specifically lab Apache access data versus lab Apache error data or any other lab Apache data. So we've run a query, simple, but we had to start somewhere. When we run the query, we have the histogram showing us for the last 15 minutes or for the time period, the amount of messages that returned or matched, broken out into 1 minute chunks. So we have our last 15 minutes in 1 minute groupings. And then down below, we have our logs. So for each log, we're going to get, by default, we're going to get the time from that log message, and then the raw log message itself. And what we see are about 8,000 logs from the last 15 minutes. Okay. And now we're going to get a little more advanced because we're going to do lab 1-2. What if we want to look for client errors? Now, what is this Apache access data? I didn't actually mention that yet, and I probably should. Why are we using this data? Well, Apache access data is essentially web server data. When you go to a website, this is a record of your transaction of visiting that website. It's going, oh, actually, before I tell you what's in there, let's look at it together. So let's look at the first log message. Now, it doesn't really matter which log message we look at because all the data is going to be the same in that it's going to be formatted the same way. We might have different values here, but each log message is going to follow a structured format, which is really important in logs. So let's look at the first log message. And do we see anything in this log message that might be valuable to us? Remember, this is web server data. So we see an IP address right here, for example. I recognize that as IP address. You might not. Hopefully you do if you're taking this class, but you know, there's an IP address. Here's time information. So here's the day it's from, the message is from, the time, the milliseconds, the time zone as well, et cetera. Now this is web server data. This value right here, you know what it is. Even if you don't know what it is, you know what it is. Now, you might not recognize it when it shows it at 200, but a 200 is a good value here. This is a successful connection. When you go to a website successfully, you get a 200. Now, when you go to a website unsuccessfully, and you've ever gone to a website and got a file not found or page not found, you probably know what status code is going to show up here. It's going to be a 404, which is an indication of a client error. And there's many other status codes. We don't need to know all the status codes for today. We will use some of them, but it's not important that you understand them. But just want to point that out. So this is web server data. So in lab 1-2, what we want to do is we want to look for client errors, and we want to look for 404s. What we can do is very simply just add the string, or the two strings, I guess, of end 404. So if I want to look for 404s, I do end 404. When I hit enter, I'm still looking at my Apache access data for the last 15 minutes, but now, or end now, I'm also looking for the string of 404 in those log messages. And so I now have less log messages returned, and each log message that is returned is going to have a 404 somewhere in it. And so I'm starting to use the filtering to boil down or distill my results into what I want. So now instead of looking at 8,000 log messages, I'm looking at just the 404s that happened in the last 15 minutes, and that's just 200 of them. Now, something else, there's a lot here. The word end. The word end here is not required. I can remove it, and it's the exact same thing to the system. We would encourage you to add the word end, especially as and spelling it properly, as a new user, just to kind of remind yourself that it does exist, but the system responds exactly the same with or without it. Okay. Now in lab 1-3, we're going to introduce or start to utilize Boolean logic. So what if we wanted to look through our logs and look for the word, or I keep saying word, but it's really the string of error or check or check out. How do we look for those three words or strings? Well, the query is going to show us how to do it, but let's go ahead and grab it. So I'm going to copy that query. I'm going to do a new log search. And like I said, I'm going to do a lot of new log searches. It's cleaner. And I'm going to paste my query in. Now, when I run this query, I have my end statement. So here I'm looking at my Apache Access data. And within that set of data, I'm looking for the word error or the word check with the star with it. And the reason I'm using check with the star is because I want to look for check or check out. Do my log messages match that criteria? These do. These match the word check out. And so that matches here. Now, theoretically, not even theoretically, if we were looking for the word, not just check or check out would show up in these results. So we're saying look for check or check out. If we ran this with check star, theoretically, if the word check in or check up showed up, that would be retrieved in our results as well. Also, I see the question, case sensitivity, the search is not. So I can go ahead and do this. And it should bring back all those checkouts as well. So wildcard used in probably every other system in the world in its own way. And so that's what essentially it's acting as here, excuse me. Okay, lab 1-4. What we're going to do now is we're going to look at a new set of data. It's source category lab Apache still, but this time it's lab Apache error, which is just another set of Apache data. Now for this one, we want to look for the last 45 minutes. So what I'm going to do is I'm going to grab my query, my single line. I'm going to do a new log search. Now, I want to do the last 45 minutes, and I told you the default is the last 15 minutes. Now, how do we modify that default? By clicking on it. When we click on this time portion here, we can modify this. We have the ability to modify it in many different ways. And that's something that's a common theme in Sumo, is the ability to do things in multiple ways, good and bad. Actually, it's good, it's helpful, but just you can do things multiple ways. Now, in this case, I want to select last 45 minutes. And if I choose this relative time range, or when I choose this relative time range, I see various time ranges, but I don't see what I want. Another way I can select time is I can use my custom range. I can start to use a calendaring feature and say, show me data from February 1st to February 16th, and midnight to midnight, or whatever. But in this case, I can use this much simpler syntax to display the time that I want. When I click on it, you'll notice I have the syntax here of -15M. Well, I can use that syntax to look for different minute periods. So if I want to look for the last 45 minutes, I can just do -45M. And now I'm looking for the last 45 minutes. Cool. Let's see, there's a question about finding the locations after the slash. Let's see, I think we do an example with that shortly. I think we do something with that shortly. So we'll take a look at that. And I'll address that at the break. It's a good question, just not one I want to answer right now. So let's take a look at, I'm sorry, we were in lab 1-4. So we just ran our query for our error data. And so now we see log messages down below, formatted in a little bit differently than our access messages. But once again, we see the word, we just see our Apache error messages. Now, what we want to do in lab 1-5 is look at two different source categories. We want to look at the access data, and we want to look at the error data. Now, I'm going to grab this query. I'm going to paste it in, but I'm going to talk, well, as I've been doing already, talk about it. Let me grab this query. Let me paste it in. Now, before I run it, I am looking at, or I want to look at error data, and I want to look at access data. Now, before I run it, I'm going to remove this or. And what I want you to think about is, if I run the query right now as is, what data am I going to get returned? Am I going to get error data, Am I going to get access data? Am I going to get both? Or am I going to get neither? Lots of different answers, and the answer is neither. The reason being, remember, there's the end that's assumed or implied. And what I'm saying here is show me data that exists in Apache error and exists at Apache access at the same time. And data can't reside in two places at the same time. So that's why we go ahead and utilize the or here to say, show us data that's here or there. And now we get both sets of data. So I want to show that. It just hopefully illustrates the or feature and the difference between the and. Now, that being said, and actually the question that was asked earlier is, what if we want to go ahead and look across both source categories at the same time? Well, we can utilize our wildcards. What we can do here, new query again, is source category equals labs Apache star. When I click start, I should be getting Apache access data, and I should be getting Apache error data. I should also be getting anything like lab Apache random or lab Apache start or lab Apache whatever, everything after the slash. Now, how can I see what is included with everything after the slash? What I can do here is I can utilize my field browser. Here, I ran this. How many source categories did I get back? Well, I think I got back two, Apache access and Apache error, but maybe there's a third one. When I go to my field browser and go to source category, I see there's only two values. If there was a third or a fourth or a 10th, it would show up here, but it doesn't. And so this is one way for me to see what data I have or what is after the slash. Many other ways to do it, but this is one way to do it. All right. Now, this next query, I am going to run very quickly. And if you notice, I'm rushing, but there's a reason I'm rushing. And let me go back to the query to show you why I just did this. Let me make sure it works first. There we go. Okay. So let me go back a step because I ran ahead, but there's a reason. What we want to do next is we want to introduce LiveTail. Now, when I do my query, and I'm going to grab this query to demonstrate my LiveTail, but I can still use this query before I get into my LiveTail and to show what LiveTail is, because I've said the word LiveTail a few times, but I haven't really explained it. When I run a query, I do a new log search, I paste my data in, and I click start. I am now looking for old data. I'm using kind of air quotes when I say the word old, but it's data that's come in. It's been ingested, it's been processed by Sumo Logic, and it's essentially been sitting around for up to 15 minutes. Now, it might have come in a millisecond ago, but it has arrived, and like I said, it's been processed and basically sitting there. Now, what LiveTail is going to give you the view into is to see data as it arrives into Sumo Logic before it turns really into a message, or yeah, really before it turns into a message. So LiveTail gives us the ability to see data as it's being ingested into Sumo Logic. And that's what I'm seeing right here. Now we have test data. We don't have much being generated, but we're starting to see these log messages come in. Now, the reason I jumped ahead to do this is we have a concurrency limit on the amount of LiveTail sessions that are allowed, which is, I believe it's currently 10. It changes every now and then. So we can't, or you can't have more than 10 users run a LiveTail at the same time in a specific organization. And it's not really a problem. LiveTail isn't used that much, but it is used. And I just wanted to kind of bring up that limitation, or that, I guess, limitation / feature. So LiveTail is a really good way to see what data is coming in. LiveTail is also a good way, one way, I guess you could say, to start to utilize the wildcards here to start to see all my lab Apache star data. This is going to include my error data. This is going to include my access data. And if there was any other data, this would show it as well. So another example of where you can utilize wildcards. So some of you may use LiveTail, and some of you will think it's the best feature we ever added. Most of you will never use it again, and that's fine. But I did want to point that out because it is helpful for some of you. All right, that should conclude lab 1. Yeah, it does. So we have quiz questions for most of these labs. So we'll go through them. Most of the answers I remember, some I forget every now and then, but let's try and get through these together. So quiz questions, the first quiz, and these are going to, I think all of them are true or false questions. Keywords are case sensitive, true or false? That's false. We demonstrated that a moment ago with the capital E in error. And of course, you can demonstrate it for yourself. And is implicit and or is explicit. True or false? And so that's true. Keywords and metadata can use wildcards for live tail. This one kind of goes back and forth. Essentially, it is true. So you can use wildcards in the live tail as you saw. So cool. All right, let's see. Oh, there's a question about can a user run as many live tails as they want at once, or would be a max of 10? It would be a max of 10 for a user across or the organization. So if one person runs 9 live tails and another one runs 1, you're at your limit. It's also just not a limit that you'll run up against very much. You can actually ask our support team to bump it up. It sounds like something you'll run into, you just won't. But if you do, just let our support team know. And like I said, they can increase it. Oh, how do you start live tail? Let me demonstrate. I went through it kind of so quickly. So this is where you can use plus new and live tail. So like I said, today we're using log search, and we will 99% of the time. I kind of forgot about the 1% of live tail. So when you click it or start it, it just provides you a blank dialog box. And now anything you type in it will be searched. So I mean, I can just do, oh, you do need to use a proper filter. So you do need to use source category or something like that, some sort of metadata. And then to close it, of course, it's just Xing out of it. All right. So that's lab 1. I know lab 1's a big one. The next few labs are actually quite cumbersome, but they're useful. So let's continue with lab 2. And lab 2 is having us now dig deeper into our data. So we now have our Apache data. We've now queried it. We've kind of confirmed it exists, and we can pull results back. Well, now let's go a little bit deeper into the data and start to do something with it. So in lab 2-1, another question about live tail. Who justifies which live tails would be ran if there's so it's basically first come, first serve. You have a concurrent limit of 10 live tails, and once you hit that, you've hit it. So cool. All right, so lab 2-1 is introducing, in this case, it's actually introducing our count operator, which is a really important operator. I guess they're all important in their own way. But let's go ahead and look at this operator. I'm going to just copy the query and kind of talk through it like I've been doing. What we want to do here is we want to look at our Apache our Apache logs, not just access log, Apache logs, and we want to count our results by source. So I'm going to go ahead and copy this all in. I'm going to do a new log search. I'm going to paste this whole query in. But what I'm going to do here is I'm going to use 2 backslashes. What these backslashes are doing is commenting off this line or turning off this line. When I run this query, it's going to act as if this second line does not exist. And what I'm going to do is run the first line, talk about it, then run the second line and talk about it. So when I run the first line, like we did earlier, we're looking at our lab Apache data, all of it. Now, what if we want to count by source? Well, I showed you how to use the field browser, but this is how we can do it in a query. Very simply, when we count by source, we are going to do exactly that. So when I click start now, I'm going to have a new tab. The new tab is shown because I'm doing a count. The new tab is called aggregates. When I do any mathematical operator, and count is a mathematical operator, aggregates shows the results of that math. So what I now see is over the last 15 minutes, there were only 2 sources of data, Apache access and Apache error, as well as the counts, how many messages showed up. If there was a third one, if there was an Apache random, Apache start, whatever it might be, that also would show up here. And so now we did a grouping. And then what we want to do is we want to actually go back to, not go back, but in lab 2-2, we want to utilize the, actually we can use the same query here. Yeah, let's use this one. So lab 2-2, what I'm going to do is I'm going to do the same thing as I did earlier. I'm going to copy the query, I'm going to paste it in, and I'm going to talk through what this query is doing. So new log search, 2 slashes. I'm going to run the first line. Now, once again, as I've done a few times, and you have done, when I run this, I get all my lab Apache data, error data, Apache access data, both. Now, the next thing I want to do is I want to start to utilize parsing. What parsing is going to do is let the system, or we're going to let the system, or force the system, I guess, to create fields and essentially create key value pairs. So for example, here's a log message, and you should have a log message in front of you, maybe not an exact one, but one of these log messages is going to have, as I pointed out, an IP address in it. This one doesn't, this one does, this one does, but some of these have IP addresses. Now, as I mentioned, I recognize this as an IP address, and I hope you do, being in the technical industry. If you don't, that's fine. Don't feel critical about it. But we know dot is an IP address. Now the system doesn't. The system is kind of dumb. Now there's very easy ways to make the system smart, even easier ways than we're about to go through. But by default, the system is kind of dumb, and we need to tell it, "Hey, system, this is an IP address. Number is an IP address." Now, how do we do that? Well, here's one way we can do it. Once again, many ways to do the same thing. What we're doing here is we're taking advantage of a feature called regex, or regex, depending on how you pronounce it. It stands for regular expressions. It is not a Sumo logic thing. This is not something we came up with. We do not want credit or blame for it. What it is a very simply, it's a pattern matching system that some people love and some people hate because it's very picky. But what it's doing is allowing us to create a criteria that we want to match and we want to equate to an IP address. And that's what's happening here. What we're doing here is we're saying parse using regex. And we want to create a field called IP address, or more specifically, IP underscore address. How do I recognize an IP address? Well, by recognizing number. More specifically, looking for 1 to 3 digits, .1 to 3 digits, .1 to 3 digits, .1 to 3 digits. Now, just to be upfront, and if you want to really get technical on it, if hold on, sorry, I got over. Here we go. If this value showed up as an IP address, and once again using air quotes as an IP address, the system would recognize it as one, even though it's not one. It's in the format of one, but it's not. The values are too high. But what we're using is just a very simple scheme of saying, look for this and call it an IP address. When I click start, the system is now going to go to each log message, and it's going to say, okay, can I find number. If I can, retrieve the log message and create a value or a field with a value called IP address, and the value will be that IP address. So here's the IP address, here's the IP address, here's the IP address. And what we can now do is count them. We can do many things, of course, but what we can do is say count the IP address. When we do count, once again, we're doing aggregation. Now we see all the IP addresses that are in the system from the last 15 minutes, as well as the count, how many of them appeared. And we can sort these high to low, low to high. And now we see this IP address showed up the most times, second most, and so on and so forth. All right, let's see a couple questions in there. One question is, what is D here is for digit? That's about as deep as I'm going to go with regex. It's like I said, it's very well known. It's very, very thoroughly documented. It's also just very specific. And so I am not a regex expert, and many people know regex better than me, but if you do know it, you can use it. Now, if you don't, that's perfectly fine. We're going to show you alternative ways to get the same or essentially the same data, but I wanted to show you this way. So if you use the regex and you like it, great, you're going to be happy. The question was, is IP underscore address a reserved keyword? Nope. So we could have called, no, it's not, period. And we could have called this whatever we want. Can we do the same regex for a JSON message? JSON is even easier to do. I think we'll show that later. And let's see, what else do we have in here? Oh yeah, well, this would need to be. So, if I'm going to call the field IP, whatever, I need to count by that same field name. Let's see, does the parsing occur from the log message or from the selection of the IP address on the left bar? Let me point out something that you guys are noticing, which is good, but let's show you, let's discuss this. Let me go ahead and let me kind of reset myself here. Actually, yeah, let me just reset myself here. Now, actually, let me okay, what I'm gonna do is I'm gonna remove this field. So what we're doing is we're looking at our lab Apache data. Now, what some of you are noticing is you're saying to me, hey, there's a field already here called source IP. It has IPs in it. Why are we creating a field called IP underscore address? The reason we're doing it, is we want to show you how to do it if this feature over here wasn't working. Now, this feature over here is taking advantage of something we call a field extraction rule. We're going to talk about them soon, probably about 20 minutes. What field extraction rules allow you to do, or somebody in your organization do, is parse the data as it becomes ingested. So once it hits the live tail, the next thing it's going to do is look through the log message and say, this is the IP address, this is the status code, things like that. Field extraction rules are great. We encourage you to use them so that you don't have to parse this way. But if you're not using them, you do have to parse this way. And so we want to show you both methods. And so we would encourage you to use this bar. And so, yeah, if you wanted to do count by IP addresses using that source IP, what you could do, and I think some of you are kind of figuring out, is you could just do this, where I'm saying, look at my Apache data, look or count by my source IP. Now, that being said, there's a limitation here that I don't think you've noticed. Some of you, this can be sarcastic, think you found a smart, you outsmarted me, but there is a limitation here that you're not, might not be thinking of. And what is that limitation? This source IP is not attributed to Apache access and Apache error data. It's only attributed to Apache access data. So when I say show me the source IP, I am only going to get Apache access data. I will not get an Apache error message. I could very easily modify the rule so that it does show it for both, but I haven't done that here. And so that's just a kind of just a gotcha, I guess. Yes, and also a better way to do it would be to sort. So we're so off the rails, but it's okay. What we could also do is sort those to just see them visually better as well. So good call, Giles, on that. All right, let's get back to the lab because we have got a little wacky, but we're good. So what I'm going to do is I'm going to repaste the query in. Actually, I'm just going to rerun it. Yeah, I'm just going to repaste it in just to say we're done with that step. Because now we want to go a little bit further. So at this point, we have all these IP addresses that are showing up. However we got them, we have the IPs. But let's say we want to take this further. What if we want to start to filter out values? I have IP addresses. If I click on the count column, I can sort high to low or low to high. But let's say I don't care about IP addresses that are showing up single digits or double digits. That's just not relevant for my use case. Maybe it is, maybe it isn't. What if I only want to find values that are greater than 500 or less than 500? What I can use is the where count. So I'm going to copy the last line here. So what I'm doing is I'm introducing a where clause. If you know SQL, you probably know our Sumo language query pretty well. When I run this, the system is going to now look through these counts, these values that got returned, and it's going to say only show it if it's greater than 500. If it's less than 500 or 500 or less, leave it off. And now I see these values. I could also take this arrow and turn it around and say only show me those values that are less than 500. And I can, of course, use any value. It doesn't have to just be 500. But that's a way for us to start to filter our value or filter our data. Now, what we want to do here is remind you, remind you if you haven't seen this before. As I mentioned earlier, sometimes expressing your data through charts or graphs is better or easier. So while this list might be helpful, I'll just turn it through. Maybe it's not. Maybe we need a better illustrative model. And so we have these various options over here. And we could look at this as a bar or a line graph, or which we want to point out here as a pie chart, or really more specifically a donut chart. And now, if our job was to tell somebody, hey, these are over the last 15 minutes, these are the top 4 IP addresses that are showing up most frequently, and percentage breakout and do something with it. All right. Cool. So let's go. Let's see. Well, let's do the next lab. Yeah. Good question or a point, Matthew. The question, or it was a point or observation, how to do a new line. So when you want to do a new line, you're going to do shift enter or shift return, and that will create a new line for you. If you just do enter, that's going to run the query. Now you do have the ability to modify that. In fact, when we're doing tangents, let's show you. What you can do is you can go to your user under preferences, and right here is the preference you can adjust, either in our training account or in your live environment. Do you want enter to run the query and alt enter to create a new line, or vice versa? And so based on what you prefer, you would select that option. All right. Let's see. All right, so let's go back to the lab. Let's see. And let's do lab 2-4. What we're going to do here is we're going to do a new query. And what we want to do with our query is look for the top 10 source IP addresses by bandwidth usage. And so what we're doing is similar to what we were doing earlier, but taking it many steps further. So I'm going to copy the query. I'm going to go back into Sumo. I'm going to do a new log search. I'm going to paste it in. I'm going to comment off these lines so I can go line by line. And then, as we've been doing, just talk through them. So the first line is looking for lab Apache access data. That line is going to be repetitive. We're going to be doing it many more times, but now we're looking at our data, looking for our data. Now, the next line, what we're doing here is we're using this parse regex that we just talked about. Once again, as described, we don't necessarily need to use this method, but we want to because I want to show you it. So now I have log messages that have status codes or IP addresses, excuse me. Now, the next thing what I want to do here is I want to start to parse these messages even further. In each log message, after the status code is going to be a 4-digit number. It doesn't have to be 4-digit numbers, but typically it is. What this 4-digit number is representing are the bytes or the size. So when you went to visit this website, how many bytes did you utilize or were transferred? Now, how do we tell the system to recognize this item right here as size? Field extraction rules are the greatest way to use it because it'll do it automatically, but that's not the point of this lab. What we want to do is we want to show you another alternative to doing this. Now, you could find this using regex. It would be a complicated regex, but all regex is complicated. What we want to do here is we want to utilize this 200. This 200 is a successful web connection. And so what we want to do is we want to use this 200 as what we call an anchor, and we want to use a parse anchor. So basically, we want to use the quote here, the space, the 200, the space, and then we want to tell the system, look for that next thing. That next thing is going to be the size. So when I click start after enabling this third line, the system is now going to look for those 200s in that spot, look for the next thing, which is going to be that 4-digit number, and display it. And so now for each log message, we have a size and an IP address. And those are now fields that we can utilize. And now we can utilize those fields. So how do we want to utilize those fields? Well, remember, we want to look for top 10 IP addresses by bandwidth usage. Right now, what I have is an IP address and usage, but I don't have by IP address. This IP address could show up 40 times. It could show up 1 time, but I don't really know. And I want the system to help me with that. So what I'm doing here on this next line is having the system start to help me with that. What I'm doing here is I'm saying take the size and add it up and call it total bytes. I'm about to create a new field or a new field called total bytes. But I want to do this by IP address. So now when I click start, since I'm doing math, I'm going to have a new tab called aggregates. And in that tab, I'm going to have an IP address, and I'm going to have my total bytes, which is going to be all those 4-digit numbers added up. Now, in this case, I have a pretty extensive list still. I have 25 IP addresses. Well, what if I want to see the top 10 IP addresses? Well, I can use top. Top is an operator. I want to find the top X, the top what? The top 5? No, the top 10. Do I want to find the top 10 status codes? No, that's not really what I'm doing here. I want to find the top 10 IP addresses. And then do I want to find those top 10 IP addresses by status code? Well, no, I want to find it by total bytes. Now, when I click start, the system is going to take that list of 25, sort it, keep the top 10, and drop the bottom 15. And now we have our list. There was a question about using the sum size, or can you just use the size? You can't just use the size, you have to use the sum size because the sum is going to represent the mathematical calculations. And so that's what's calling, that is the operator there. Sum is the operator. Now, related to that, sort of, let me find it real fast. And I don't want you to follow along here, although yeah, you can, but let me paste this in the link. What I want to do is I want to provide you a list of the operators in the form of cheat sheet. So what I have here and what I just sent in the chat is a list of the operators. And so for especially it's kind of focusing on what was just asked, for aggregating, here are a bunch of different ones. So average, count, sum, etc. We're not going to go through all these operators, so not even close, but this is a list of them. So just in case you're curious. All right, let's see. I think we're just about done with that lab. Yeah, we are. So this one doesn't have a quiz, so I'll skip over that one. And now we're going to jump into lab 3. Lab 3 is going to go over parsing, as we've been doing already. So now we're going to start to get a little bit deeper into parsing, talk about field extraction and JSON and other methods. So we should be at lab 3-1. What I'm going to do here is I am going to show 3-1 in my own way. Yeah, let me just show it to you because I mean, you can read all this, it's accurate, of course, but let me just demonstrate what I want to show here. I think you'll see what I want to show quite quickly, especially those of you that are interested in JSON. All right, what I want to show here is the source category. Now, we looked at Lab Apache Access data earlier, and when we ran it, we had our field browser showing us those various fields. Very cool. What I want to show now is CloudTrail data or AWS data. It doesn't have to be specifically CloudTrail. I just want to run it. Now, when I run it, I have all these fields available to me. Now, in this case, I do not have a field extraction rule set up. What is happening here, and you can actually see it occurring in the message itself, is JSON just by default, or the way it's created or designed, exists in key value pairs. So here, for example, in the JSON message is a field called source IP address, and here's the value for that IP address. This is AWS data. Here's a field for AWS region. Here's the value for AWS region. Now, since this is in a JSON format and these fields are automatically extracted, I can use these parsed fields automatically and much easier. If I want to count by AWS region, I can just say count by AWS region. The system knows what an AWS region is. It knows how to locate it and will identify it for me. Conversely, or actually, not be conversely or similarly, let's say we have this IP address and I wanted to extract the IP addresses. I wanted to count all the IP addresses. Now I could still use my regex here and I could say, look for number, 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 number. That would still work. I could create a parse anchor here. I could say, look for the word source IP address colon, look for space, look for quote, and that's the IP address. Or what I can do here is once again, just use the field as it's already been defined for me. And so now if I want to count by source IP address, I can go ahead and do so. So this is one reason why we would encourage you to utilize JSON log messages. There's reasons why you may or may not. They're bigger, so they take up more size, which is not always a benefit of them. But this is one reason why they're helpful, is they have the built-in parsing automatically. And so that's now how I can parse my JSON log messages. So quite easy to do. It's automatic. Encourage you to use JSON if you can. What I'm going to do now, if there's any question, of course, please ask, but let's do lab 3. Lab 3-2, lab 3-2, 3-2, 3-3, 3-4, and 3-5 all go together. So I'm going to go ahead and grab the query here in 3-5. Let's see a couple questions here. Let me go back to the lab. The question is, what is the log message? Is a JSON string? So let's see. So here we see our log messages. We have the ability to view them in raw, but we should also be able to view them in JSON. And so we just will kind of know that they're in a JSON format. And it's a format that you can utilize for log messages. It will be decided on prior to getting the data into Sumo Logic. How do you display the hidden fields? Very simply, clicking on the checkbox. So if we want to display that AWS region, click on the checkbox, and now I have that field. This is just displaying it. Regardless, if this is unchecked, I could still use the source IP address in my query, but if I do want to show it, that's how you do it. Probably easier than you were thinking. So good question, though. Very good question, because I had not shown that yet. All right, so let's do, we're going to do lab 3-5. And let me just show you, this is some things in 3-5 that I want to kind of show as we go line by line. So we're going to follow the same pattern. So I'm going to look at lab Apache error data, which we looked at earlier, just for a moment. We didn't really do much with it. Now, what I did point out earlier, and if you remember, cool. If you don't, that's fine as well, is there's an IP address in some of these log messages, but some of them don't. So all these log messages have time. They all seem to have bracket, something bracket, and then some of them have bracket client space with an IP address. Now, what I want to do here is I want to, once again, as I've been doing, I want to extract the IP address. Now, I could use regex for this, but I don't want to because that's not what I want to show off here. What I want to show off is what's going to happen. And I'm going to remove or comment off this no drop. So I want you to ignore this no drop because I want to show what happens before I add the no drop in. So what I'm about to run is this line that says parse client, bracket client space, IP, and that thing is going to be a client IP. Now, when I run this, what is going to happen to the log messages that do not have a bracket client IP? What's going to happen to the messages that do have a client bracket IP? Let's go ahead and take a look. When I run this, if the log message has bracket client space IP, it's going to take that value and show it to me. However, if the message does not have a client IP, it's not going to show up in here. So I'm only seeing those messages that have bracket client space IP. What if I want to view those messages that were dropped because they did not meet my criteria? That's where no drop comes in. By enabling no drop, which is an option as we call it in Sumo, when I run it, the system is going to still do the pattern matching. If it can show client IP, it's going to show the client IP. If it does not have a client IP to show, it's still going to retrieve the log message, but there's just going to be no IP address. And so this is a good way for you to see those messages that are being dropped. Dropped is good. Sometimes it may not be, but this is a good way to see what is occurring. Because imagine, this is kind of a weird example, but let's see, let me run through this example. Imagine we created this parse client logic right here, but I accidentally put a space here. I put a space right there. And I run this, and I'm now expecting to see all these client IPs, but I'm not getting any client IPs. Why not? Well, this would be a good spot for me to run a no drop. And I should now see, why aren't these messages matching my criteria? They should, they exist, there's IPs. Why is this IP not being extracted? And then I could maybe, start to realize, oh, I have a typo in here and start to work backwards. So no drop is helpful in that case where you create a query and you want to see what data is being left out, add a no drop. If you want to then include that data, you can leave the no drop in. If you don't want to, then you can just leave it out. So now in this case, I am carrying along all the log messages, those with an IP as well as those that do not have one. Now I'm going to skip this third line. It's not really relevant to what I want to show right now, but because I want to go straight to the fourth line. What I'm using here is, it's an operator of is blank. And what I'm going to do here is basically almost do the inverse of the no drop, where I'm going to say, show me those client IPs that are blank. And so now when I click search, I only get those log messages that do not have a client IP. So wanted to show you no drop, really helpful to use, especially as you're new to creating queries, to see what data you're leaving out and deciding if you're intentionally leaving that data out or you really just have a typo, which is happens a lot. And then the is blank, which is showing us kind of the inverse of the no drop almost. There's other operators related to is blank. There's is empty, there's is null, and I think there's one more that I'm not remembering right now. All right, let me see. All right, so that should conclude lab 3-5. 3-6 and 7 are related as well. So I'm going to go ahead and grab 7. The list of operators, let me go ahead and put that in chat again. Is no drop operator used only with parse? Yes. That thinks so. It's a pretty good question. Yeah, I believe it. Yeah, it's only with a parse operator. I'll paste this in just so you can look at it and possibly correct me if I'm wrong, Surat, but good question. All right, so let's see. So we were doing lab 3-7. Now, this is a helpful feature. It's not an operator because you've actually seen this operator already. It's the parse operator again, but it's using it a little bit differently. Now, what this query is doing, once again, commenting off, is we're going to look at GitHub data, just the different set of data. You might be familiar with GitHub, you might not be. It doesn't really matter. We're just using it. Within GitHub, there's the idea of a committer, somebody that has committed or submitted new code. So I should be able to see that individual. There's the committer information. So here in this case, Kevin committed some code and other people did. Now, what I want to do here next is I want to parse. I want to parse my email address out. So here I see an email, but I want to parse it out in my log message. I want to extract the email addresses that exist. So I'm going to say use the parse, look for the word email, look for a quote, look for the word email, look for colon, look for space, look for quote. That right in there will be an email. So now when I click start for my second line, I should now have a new field called email, and I should have values that have emails in them. And I do email, email, and so on and so forth. What I can do here and what we're introducing is the ability to parse this field further. What if you wanted to take this field, and actually, I don't like the layout we do here. I actually want to redo it a little bit. But what if you wanted to take this email address and split it up into user and domain? Well, you can do that. That's what we're doing in the third line. We're saying, take the field of email that was returned in the second line and look at that field. From that email field, look for an @ symbol. If you see an @ symbol, everything before the @ symbol is going to be called a user or users or whatever name you want. Everything after will be a domain. Now, when I click start, I'm going to have two new fields. I have a user field and I have a domain field. And what if I wanted to count all the domains? Now I could very simply do count by domain. And now I see which domains are more popular. So what we're showing here is the ability for you to take a field and parse it even further, which is quite helpful, especially in this email address example. Another example I'll show later is, let's see, when we had our data, let's just see if we can find an example real fast. Probably not. Let's see, do I see one? Yeah, here. If I wanted to take this IP address or any IP address and extract the IP address and the port, I could use a very similar expression as I did right here. Actually, the only difference would be like that. All right. Cool. Let's see. Now lab 3, 8, and 9 go together. after these labs, we begin to kind of speed up a little bit, so they do get faster. So I'm going to grab 3-9 and just once again talk through it like I've been doing. And I hope this is effective for you. We'll take a break in probably about 10 minutes. So let's talk about this query let's do and why we're showing you this. So in this case, we're looking at a new set of data, or new to us. It's called snort data. It's fun to say snort. It's security event data. It's not Sumo logic data like Apache. It's just another set of data we choose to demonstrate. Within this data, at the end of each log message is going to be 2 IP addresses. Here's one IP address. Here's another IP address. And with the ports as well, but IP address, IP address. Next log message, IP address, IP address. What are those IP addresses? Doesn't really matter. Let's just call them IP1, IP2. They could be source destination, host remote, whatever. There's 2 IP addresses in there. Now, what if I want to start to look at those IP addresses? I'm going to ignore this last portion because multi will use in a moment. But what I'm going to do now is use the regex like we've been doing because I want to start to extract those IP addresses. Now, remember, these log messages have 2 IP addresses. So when I run this query saying, show me the IP addresses, what am I going to get returned? For each log message, am I going to get the first IP address? Am I going to get the second IP address? Am I going to get both IP addresses? Am I going to get no IP addresses? Just kind of think about it for a second. Well, let's see. So I'm going to run this. What's going to happen is I'm going to get the first IP address because the system is going to go ahead and attempt to match. So the system is saying, okay, in the first message, can I find an IP address? Yep, I found one. I've completed my mission. Let me go on to this next log message. The next log message, can I find an IP address? Yep, and so on and so forth. Now, what it's doing is it's ignoring the second IP address. Intentionally so, because we're saying, look for the first occurrence. But what if we wanted to pull out that second IP address? How do we do that? Well, this is what the multi-operator does. Or it's really an option. I guess it's not an operator. But what it says is look for multiple occurrences. Now, the way it displays the data is going to be a little bit weird. We'll look at it in a moment, or right now, but let's talk about it. So when I include multi, here's my first log message. And the first IP address is 123.222. There it is. The second IP address is 10.72. And here it is. So here's the first IP address. Here's the second IP address. In the next log message, here's the first IP address. Here's the second IP address. So the system shows that we have 3,000 log messages, but in reality, we only have about 1,500 unique IP addresses, or 1,500 IP addresses. We don't know if they're unique or not yet. But multi is going to allow you to do that. So if you want to look for multiple occurrences. So if you want to treat an IP address as an IP address as an IP address, then multi is going to work great. Now, the next question you're probably going to ask me is, what if I don't want to treat them the same? What if I want to treat one as a source IP address and one as a host, or IP1 and IP2? This is an example where you would want to choose a different parsing method. You could do this through a field extraction rule, but what you could also do is a parse anchor here. What I could do is I can highlight a portion of this log message, and this is probably getting overkill, but I'm still going to show it. And what I can say is this first thing, call IP1. This next thing, call port 1. IP2 and port 2. And let me get rid of that other one. And now when I run this query, this is probably what you would more expect when you were looking for IP addresses. So now I see IP1 and now I see IP2s, and now I could say count, or whatever, do what I want. So I wanted to show both just because that question naturally comes up. There was a question, can I use multi with no drop? You should be able to. Yeah, it theoretically should work at least. I don't know that I've ever tried, but yeah, the two should work harmoniously. All right, last portion of lab 3, which is field extraction rules. Now we've talked about them, but I want to show them to you. I think this will illustrate them a little bit better. Now, in the real world, you might not have access to this. This is something that an admin, your admin, could say, I don't want you doing. Something I wouldn't really encourage that they restrict it, but they could. What I'm going to do here is I'm going to go to the black bar, and I'm going to go to manage data, and I'm going to go to logs. And when I go to logs, once again, you may not have all these options in the real world. I'm going to go to field extraction rules. And what I see are these rules that I or somebody in my organization has put in place already. As you see right here, there's a rule that's locked for JSON. It auto parses. We recognize JSON, we automatically parse it. But everything else needs a rule created. But there's easy ways to create the rule. So let's go through. Oh, I don't have. Let me show you. Let me log out. So we did disable this functionality, as you're probably noticing right now. Well, for a few reasons, mostly for security reasons. But let me go ahead and show you the process, and I think it will be illustrative enough. And then we'll take that break. We're coming up on that. So if I had access, I would go to manage data. I would go to logs. I would go to field extraction rules. And let me show you, like I said, how to add one. So I'm going to add a rule. I'm going to give it a name. Not very creative. I can decide when do I want the rule to run, ingest time or runtime. Encourage ingest time, but up to you. Now I can go ahead and specify my data. Let's say I want to set this up for Lab Apache Access data. Access. So now I'm telling you what data to look at. Now here I need to, or I should, well, I need to provide a parse expression. I need the system to take all that data, that Apache data, and figure out what it is and understand it. Now I can create my own expression from scratch, but I don't want to. What we want you to do is take advantage of the fact that we know what an Apache Access log message looks like. And so you can use that structure already. And so as we see, here's the structure. The system's going to look for an IP address. It's going to look for a status code. It's going to look for a size, and et cetera. And now when I say use this template, now going forward, this only happens going forward. The next time Lab Apache Access data comes in, the system is going to try and find a source IP field, looking for number, status code, a size, and so on and so forth. So field extraction rules, really good, really important. If you're not using them now, tell your admin you should be. Very thoroughly documented, just a big plug for them. So. All right, let's go back to lab 3. And I'm sorry, the lab itself shows a demonstration of them. We've talked about them, but we didn't actually kind of officially use them. And so this is why how we can officially use them. So this is how I can go ahead and say, excuse me, look for Lab Apache Access data and status code 404. Now, we're going to go backwards before we go forward. When we ran this first lab over here of looking for client errors with 404s, this lab was actually incorrect. In this case, we were looking for the word 404, the string 404. And we were seeing 404s as such in the status code field. If 404 showed up in the milliseconds column, this query would have retrieved it. But using the field extraction rules, we can now more specifically say, show us status code equals 404 to really specify what we want to what that 404 represents. So want to show that field extraction rules, good, please use them. All right, let's do the quiz. First quiz, these are true and false again. CSV, JSON, split, and key value are all parsing operators. This is true. We really just looked at, actually, we didn't really look at any of them. I guess we sort of looked at JSON, but they are true. Once a field has been parsed, it cannot be parsed any further. This is false. We saw that in an example with the email of parsing it to an email and then using the internal portion of the email @ as an anchor and parsing it further. And then fields parsed by the field extraction rules are available in the field browser. Well, better believe they are, because that's how you guys all noticed that these fields exist and asked why we're doing double work. So you noticed that. So good on that. All right, let's see, where are we at? Lab 3, like I said, I think we'll take a break now. Yeah, we'll take a break now. We'll come back. The next labs, there's not as many parts to them, so they will move a little bit faster. So let's do I think we can still do a 10-minute break. We're still, yeah, we're still good for that. So we'll take a 10-minute break. I'll put myself on mute. I encourage you to get a snack, grab a beverage, and then we'll come back and finish up. If there's questions, feel free to post them in and put them in the chat, and we'll address them once we get back. So see you all in about 9 minutes. Thank you, everybody. Welcome back, everybody. Hopefully you had a good little snack or break or what have you. We're going to continue. So let's go ahead and look at lab 4. So lab 4 is going to introduce the idea of conditional operations. We're going to go through lab 4-1. 4-2 is, or actually we even renamed it to optional. So let's go through this 4-1. I'm going to show what's occurring here. Once again, I think just visually is helpful, of course. But what we want to do here is we want to look at our lab Apache access logs for the last 60 minutes, and we want to look at successful HTTP requests, which have a status code of 200, versus error HTTP requests that have a status code of 404. So I'm going to show this query that's helpful here. Now, many ways to do a similar query, but this is the way we want to teach you. So let's go to do a new log search, paste it in, and then we're going to go line by line as we've been doing. So we want to do last 60 minutes. Doesn't really matter too much. I guess we should follow the directions, but we'll choose last 60 minutes. And I'm going to run line by line. First line is the Apache access data, which is there, and so I'm getting it. The next line, what we need to do is we need to parse out the status code. Now, technically, as we discussed with field extraction rules, we don't technically need to do this step since the system has already done it for us, but I wanted to show the step and imagine if the field extraction rule was not working. So regardless, either way, if we want to include line 2 or not, we now have our log messages and we now have status codes. Now what we want to do is we want to use the conditional operator here. And we're going to use it twice. And so line 3 is going to be the first example of it. What we're doing here is we're saying, look for the status code, or look at the status code. When you find the status code, create a new column called successes. We're also going to create a new column called client errors. And in order for a success to be something to be deemed as a success, it needs to be a status code 200. What we're doing here is we're using Boolean or binary or true false, however you want to kind of talk about it, to say 1 for true, 0 for false. So I'm going to run this line because I don't think my explanation was that great. When I run the third line, I have a new column called successes. The system is looking at the status code. If it finds a 200, it's going to put a success of 1. If it finds any other status code, it's going to put a success of 0. Now on the fourth line, I'm doing the same exact thing. I guess it's not the same exact thing, but basically the same thing, except I'm about to create a column called client errors. And the system is going to look for 404 to identify a client error. So now when I click search, I'm going to have another new column called client errors. Here is a status code of 500. Is it a success? Nope. Is it a client error? Nope. Here's a 404. Is that a success? Nope. Is it a client error? Yes, it is. And then we have 200s that have a 1 here and a 0 there. What we're going to do now is very simply just do math as we've been doing. We're going to take the success column and we're just going to add all the successes up and call it success count. We're going to take the client error column, add all client errors up and call it client error count. And now when I run this, what I get is over the last 60 minutes, I see there's been 22,000 successes and 952 fails. Now, once again, other ways to come across the same data, but this is a useful way. And we're going to use this method a little bit later as well in our final lab. So, not something you're going to use every day, but you can if you want to. It's a helpful feature. The as here is acting as us naming the results. So I don't know if you caught that. But what we're doing here is we're saying, do this logic, this conditional, and call the new column as. So as is acting as that name, call it successes. We can call it whatever we want. We can call it Bob. Any name is fine. Obviously something that's sort of relevant to what you want to identify. All right, cool. That's lab 4, pretty straightforward or sort of straightforward. Lab 5. Let's see, we're gonna skip around a little bit here. So we're time we're okay, but I'm gonna jump to lab 6 and then I think we'll come back to 5 a little bit later. So let's go to lab 6. So lab 6, lab 6, lab 6. What Lab 6 is going to introduce is the geo lookup, which is a really great, not an operator, but it's sort of an operator. Geo lookup is an operator. But I want to show how to do this because it's really simple. It's really effective in presenting your data. And what we're going to do basically here is create a map. And I want to show you just how easy it is to do. Here's the query to do so. This query is actually longer than we need. We could remove about 2 or 3 lines from it, and I'll show you which lines we could remove and why. Let me go ahead and paste it in and talk about it again. So how do we create a map? Well, we're going to look at our Lab Apache Access data again. We can look at any data, of course, but we'll do Lab Apache Access data. Now, what we need to look at a map or create a map is IP addresses. We need IP addresses. How do we get IP addresses? Once again, many ways to get IP addresses. We could use the field extraction rule that's already grabbing the IP addresses for us. We could say, look for number.number.number. In this case, we're using a different parse anchor. We're saying, look for something, look for a space, look for a dash, look for a space, look for a dash. If you find that, that first thing is going to be an IP address, or more specifically, a client IP. We can use any name we want. When I run this, I now get my IPs. What I'm going to do now is I'm going to use the lookup table. And that's what's on the third line. And this third line reads easier if you read it from right to left. What I'm doing here is I'm taking my value, my client IP. So in this case, my value of 5.35, 0.2225, et cetera, and comparing it to the IPs that exist within the geolocation lookup table, which is a lookup table that houses geographic information. From that geographic information, I am telling the system I want latitudes and longitudes. There's other geographic data I could get. I could get country name, I could get country code, city, state, all kinds of geographic data. But in this case, I need latitude and longitude. When I run this, the system is going to utilize that lookup table and extract the data. So here, this client IP address shows the latitude and longitude of such. This client IP address, latitude and longitude of such. What I'm going to do next is just count those IP addresses, count those latitudes and longitudes, group them together, which is what the counting is doing here. So this counting is saying, look for a latitude, look for a longitude. If we have the same one showing up multiple times, count them. And now I have a count of IP addresses. Now, remember, I wanted a map. How do I get latitudes and longitudes from or into a map? Well, the system does it for me. When I click on the map icon, the system is going to take those latitudes and longitudes and then plot them for me accordingly. And now I have a map. I have a dynamic map. I can drill in. Get down to even, let's see, where is some street view level almost. Not almost, we can. And so now we're starting to see our data in a map, and everybody loves a map. So I wanted to show it to you. I know it was kind of quick, but it intentionally so. And like I mentioned, if we were using field extraction rules, we don't need the second line. And this sort line doesn't really do anything for us. I don't really even know why we have it in the lab. It's just a visual. It sorts the results, but then we put them on a map and sorting isn't relevant. So you could leave that line out as well. So I wanted to show that lookup table because it's cool. Well, like probably more reasons it's just it's cool, but hopefully it is an effective illustrative method. We look at other lookup methods. Actually, tomorrow, if you're going to be joining us in cloud security, we go through some other alternative methods or additional methods for lookups. And like I said, we'll cover that tomorrow. All right, so that's lab 6. If your log already has the coordinates, can you build a map with that? Absolutely. So if you already have latitude and longitude, you can get rid of this line and this line. Really pull your source category, count those latitudes and longitudes, click on the little map icon, and that's it. So yeah, it makes it even easier. Good. Let's see. Okay, so let's jump into lab. We'll do lab 7. We'll do lab 7-1. We can do both. Yeah, actually, we're going to do lab 7-2. But 7-1, we're going to skip. It's just, you can run it if you want. It's just not very cool. Let's see, there was a question about, is geolocation a keyword? It's not really a keyword necessarily. It's more of a location. So I just the wording. Yeah, I just wouldn't call it a keyword. Let me go ahead and share these labs again. And so now we're going to do lab 7-2. Like I said, 7.1, you're welcome to do. It's just not really useful. I shouldn't say it's not useful. It's not. Yeah, I'll stick with that. It's not very useful. But lab 7-2, I want to show. It demonstrates a little bit better. What we want to do here is we want to start to calculate, and in this case, we want to calculate moving averages. So we want to look at our 404 occurrences from the last 15 minutes. So how do we do that? Well, copy the query and use it, but let's go through it. So doing another new log search. I'm going to comment off, although we don't have to. The first line, starting to get repetitive. Apache access status code equal 404. You already know what that line does, or hopefully. Now the next line you may not. I'm going to put my time to last 60 minutes. What I'm going to introduce here is the idea of a time slice. What time slice is going to allow us to do, or the system to do, is look at our data in a granular bucket of time. So normally when I look at my data, I'm looking at 60 minutes. But what if I want to look at my data in 1-minute buckets? How much data or how many results did I have, not from 5:30 to 6:30, but from 5:30 to 5:31, from 5:31 to 5:32, and so on and so forth. And that's what this time slice allows me to do. The way I utilize the results of the time slice is in this third line. What I'm doing in this third line is I'm saying count. What am I counting? I don't have any, I'm not explicitly saying count size, or so what am I counting? What I'm counting are the log messages that have 404s in them. And what I'm doing here with this count is I'm saying count them and call the result error count and do it by time slice. When I click start, I'm going to have an aggregates tab because I'm doing counts, I'm doing math. I'm going to have a column called error counts, and I'm going to have a column called time, with the time representing my time slices. So here from 5:19 to 5:20, these are 1-minute groupings, we had 15 error counts. From 5:26 to 5:27, we had 19, and so on and so forth. Now, by default, the system does not put these things in time order. We need to request it. And so what we're going to do here is sort it by time slice ascending. We could do descending as well, but ascending is what we want. So now I have my minute time period and my error count. Now what we can do is we can introduce the operator, and this is not an operator you use all the time, but it's kind of helpful, which is called smooth, which makes it a smooth operator, which is a joke that some of you will get. What we can go ahead and do is we can smooth the error count as rolling average. Now, when we smooth it, what we're basically doing is saying create a rolling average. So at the first time period, there were 8 error counts. The average of 8 is 8. At the second period, 22 plus 8 divided by 2 gets our sort of rolling average. 17 plus 22 plus 8 divided by 3. Now we're getting a rolling average. Now, it might be hard to see a rolling average in this data. The average goes higher, lower. We might need another visual element for it. And this is where we can use our charts once again. We can put our data in a bar chart. We can put our data in a line chart, and we can start to better express this data. Now, we're not fully expressing this as well as we could, because there's another way to express this using a line bar combo chart. It's a bonus question, but I want to show it because I haven't really shown it yet. When you're in the charts, you have the ability to modify various aspects of them. One of them is change series. What this change series allows us to do is define what type of charts we want to utilize, where we can use a combination of column charts and line charts at the same time. What I'm going to do here is I'm going to make my errors columns, and I'm going to make my rolling average aligned. And now when I click save, I should be able to see, that's kind of messy actually, but actually if I do 15 minutes, it does show up better. But now what I start to see is my error count and my rolling average, with the line representing the rolling average and the error count, or the actual value for the errors, represented by the bars. So I wanted to show this just as another method, also as a way to start to mess around with the charts. There's other things in the charts you could change, properties, colors, legend, look and feel. And which is, for some people, it's going to be quite important. Having a specific look and feel for visual elements, you might prefer certain color scheme or what have you, and you can do all that. Start to mess around with that. All right, cool. So that concludes lab 7. Lab 8, we're going to go ahead and do. Although we're going to, we'll do it. I don't. The feature is great. The example is not the best, but we can still use it. It works pretty well here. The feature that we want to show is log reduce, and this is a really cool feature. And I think you'll see the benefit of it right away. If you attended our fundamental class, I think we covered this as well, but let's go ahead and take a look at this. What I want to do is, like I've done earlier, I want to look at a set of data. So I'm going to look at my snort data, that security event data. And I'll do it for the last 60 minutes. Now this snort data, if you remember earlier, we looked at the fact that it had multiple IPs in it. That's not what I want to show right now. It still has multiple IPs, but that's not relevant to this example. What is relevant to this example is the fact that each log message has this portion in here: bracket, classification, colon, space, some sort of classification. So I'm just highlighting a bunch of different ones. Now, what if I wanted to get a quick and easy understanding of the different classifications that exist in this data? How do I do that? Now, the proper way to do that, I'm kind of once again using air quotes for proper because there's many ways to do this, but one way to do this would be to create a parse anchor. Say, look for classification, look for colon, look for space, and pull this thing out. And a field extraction rule would do that as well. We could very easily do that and then say count the classifications. What I want to do is something even easier. And I'm going to use log reduce here. And before I click log reduce, excuse me, I have 6,000 messages. So there's 6,000 messages here. And what I want to do is I want to look for the patterns within them. And what I'm doing is clicking log reduce, and then that's going to automatically do this for me. So what's now happening is the system is now taking those 6,000 snort log messages and looking for patterns in them. And it's going to display those patterns in a moment. Here they come right away. So now what I see is of those 6,000 log messages, 3,000 of them were attempted information leaks. 1,600 of them were web application attacks, and so on and so forth. So log reduce is a really simple way for you to what we call find a needle in the haystack, where you can take a whole bunch of data and look for potentially unique log messages within it. So very cool feature, very helpful, a very important feature to Sumo Logic. We got our first patent on it. So from a patent standpoint, it was important. And so that's what log reduce does. I'm going to show it another example of it in a moment, but I just want to kind of pause here real fast. Let's see, we have a few questions from the previous lab, which is fine. The question, the color. Let me go back to my charts. Do I have a chart handy? Here's a chart. I went up to my gear icon and I went to change properties. And that gives you the ability to start to mess around with the color scheme. How did you show the error count with the trend line? Let me show that again. So what I did here is I went to change series, and this allowed me to define the chart. Now, this change series is not going to exist in every chart. If I go to a pie chart, or if I go to a map, change series does not exist, or it won't give me the same options. But in this case, it does. So, and also kind of in the weeds as far as showing you a feature, but something we did want to point out. So, okay, yeah, good with that. Okay, cool. All right, where were we? We were still in lab 8 with log reduce. What I want to show here, it's not really related to log reduce, but I don't know, we show it here. That's a weird spot for it. Let me go back to my logs. So what I want to do is I'm going to look at my snort logs. And what I want to show is a feature that we call surrounding messages. What this gives us the ability to do, hence the name, is view surrounding messages. So what does that mean? Well, imagine I have my message here related to this sentence. Actually, sorry. I have my log message now. And I see this attempted information leak, and that's bad. I don't think I'm really making a bold statement, but this is a bad thing, let's say. And I want to get more information about what was occurring around the time this happened. Because an information leak didn't just happen, something happened or executed or what happened. And then as a result, there was an information leak. So how do I do that? Well, that's where I can use this feature of surrounding messages. What I'm doing here is I'm selecting the range of time I want to surround this message by. I'm going to use plus or minus 1 minute to start with. What I'm going to see, I take a second to load. Actually, that was faster than I expected. Actually, yeah, the data is a little weird here, but it's still okay here. What the surrounding messages is allowing me to do is show me those messages that occurred prior to the message I chose, as well as those messages that occurred after it. Now, I don't have the data to back this example up, but imagine I did. Imagine the example is I see Bob logs in. Excuse me, let's take a step back. I see an attempted information leak. I want to find more about it. I do the surrounding messages, and I see in the past minute, Bob has logged in. There's an attempted information leak, and then Bob logged out. And those are the only logs I have. Well, my question should be probably, well, what the heck was Bob doing in the system? Now, it's not always going to be that binary or that obvious of, this happened, but you will start to see these trends and these stories in your data where you will start to see this happened, then this happened, then this happened. And so the selecting of the surrounding messages allows you to do that. To select the surrounding messages, you choose one of the down arrows, and then you choose the time range. And depending on how much data, your time range might be appropriate. If you have millions of records, you might just want to do 1 minute. If you only have a few records, maybe 10 minutes. So it gives you a few options there. All right. Let's do lab 9. Yeah, these are out of order. Let's do lab 9 next. Lab 9 is going to show log compare, which is a similar feature of log reduce, but not the same. That definition was, or explanation was pretty poor. So let's take a look at what log compare does. And you can feel free to do the labs here, but I'm really going to kind of just show this in one lab. There was a question about down arrows. Where are you seeing multiple? Oh, these multiple. So you can choose to do surrounding messages on the host or source category. So I could say, just show me the source category or show me the host. They're basically the groupings for the surrounding messages. All right, lab 9. And I wanted to show this log compare feature. And I'm going to show this feature. I'm going to do my own version of lab 9. Let me show you the version I want you to do with me. What I want to do is I want to look at our snort data again. So as we did earlier, we're going to do source category, labs/snort. I want to look at the last 60 minutes because I just want a round number time period. So last 60 minutes. Right. And like I did earlier, I did log reduce. Now we're going to show log compare, but I want to get to log compare. Let's start with log reduce. When I run this log reduce, as a reminder, I'm taking my data from the last 60 minutes, and the system is looking at all these log messages, could be hundreds, thousands of log messages, and grouping the messages together. So for example, as I showed earlier, there have been about 3,200 attempted information leaks over the last 60 minutes. There's been 1,500 web application attacks over the last 60 minutes, and so on and so forth. Now here's where log compare is going to come in. What if I want to compare those counts with another time period? Is 3,200 attempted information leaks in a 60-minute period a lot or a little? Is that normal? I don't know. It sounds like a lot. It sounds like a little. I don't really know. I don't have anything to compare it to. So what I'm going to do here is I'm going to use log compare. What log compare is going to do by default is look at the last 24 hours, or rather the previous 24-hour period and the 60-minute window during that time period. So what do I mean by that? It's going to look at let's say 5:30 to 6:30 today, and then go to 5:30 to 6:30 yesterday and do a log reduce for that time period as well. And now what it's just showing us is essentially the variance. In this case, over the last 24 hours, we've seen an increase of attempted information leaks. That might be bad. Why are we having more attempted information leaks? Conversely, we see a decrease of detection of a network scam. That might be good that we're starting to see these go down. And so this is giving us that insight. Once again, many ways to compare data, but this is a very simple way of just clicking buttons essentially. Now you might say, all right, why am I comparing Tuesday to Wednesday? We don't compare day to day. Week to week is more relevant. I could say do minus 7D. And now I'm comparing Wednesday from 5:30 to 6:30 to last Wednesday from 5:30 to 6:30. So log compare, really helpful feature. I mentioned log reduce, we have a patent for. I assume we have one for log compare as well. But it's a really nice way for you to have the system start to, like I said, kind of determine what's normal and what isn't. We're going to show a better way in a moment of having the system show you what's normal or isn't, but this is one fairly simple way. So that's lab 9. What we were showing in lab 9-3, I don't know what happened to lab 9-2, is the ability for you to start to look at these delta percentages. And that's what this is. It's a delta percentage. So what we could say is only show us those delta percentages that are greater than 25%. Do I care that something increased or decreased by 3%? I might not, but I could say, just show me those things that are greater than 25. That's more meaningful to me. It's just another way to start to filter data, of course. And then in lab 9-4, we were using the where is new. What the where is new is going to show us, and I don't know that I'll have an example, which, let me see. I did, perfect. The new is showing me that this thing did not happen a week ago, but it did happen today. And usually you guys are, well, not you guys, well, yeah, you guys, you usually want to know when something new happens because something new is usually not good, or you want to be aware of it. So this is a way for you to start to say, only show me those things that are new. And what we could do, and we're not going to do it, but we could set an alert that says, anytime we see something new that did not occur last week at the same time, alert us. So cool. All right, let's see, question. The question was, do we use log compare time shift together all the time? Yeah. Log compare is, the time shift is, yeah, it's part of the feature. Now you can modify the log compare and actually get, we're not going to go this deep, but you can start to compare different queries. So you could compare two different sets of data. Not going down that rabbit hole right now, but you could, get there. So, all right, cool. That should be lab 9. I know I'm going fast. I'm doing it intentionally, but I apologize. So certainly you're welcome to come back into these labs at any time. So these credentials we gave you, they're good for the rest of the month. You can get more credentials. So any labs we skip or any that you want to come back to, feel free to. Please do, in fact. Let's go ahead and do lab 10. Lab 10 is a really important lab. Not that they all are not important, but this is a really important and helpful feature in Sumo. It's the outlier operator. And I hope you've seen this in some way before. And if you haven't, that's fine. But what it's going to do is have the system start to determine what is normal and what isn't. And that's what we want the system to do. We don't want to decide, is 3,000 attempted information leaks a lot or a little? We want the system to tell us that. We want the system to learn and grow, and that's what we want to show here. So let's go ahead and take a look at this. So what I'm going to do is, as I've been doing, I'm going to grab the query, I'm going to copy it, and then you'll kind of walk through it again. So new log search. Well, let's again do line by line, just consistent. And I'm going to do last 60 minutes just to get a little more data, it looks better. So what we're doing here is we're looking for 404 status codes. So we want to look for error codes. And these first 3 lines should look familiar because we did these earlier. So we're doing our time slice, and then we're counting the results. Once we have those first 3 lines, now we see for a specific time period, how many error counts we got. So if I tell you we had 15 404s in a 1-minute period, is that good or bad? Well, you need something to compare it to, and that's where the system is going to help us do this comparison right now. So how do we get that comparison? Well, that's where outlier comes in. Outlier is an operator, and we're performing the outlier operator against the error count. Everything after the word error count are just not variables, but values that you can use to modify how the outlier is calculated. For right now, I'm going to call all of this just math. I'm going to just refer to it as math. I'll go through it in a few minutes, but just for right now, let's just say it's math. So what we want to do is now we want to have the system calculate the outlier. So I'm going to click start. The system's going to use all this math and now start to calculate and determine what is normal and what isn't. So let's start to look at these calculations, see if it's working. So for example, where are we? Here we are, sorry. Here, at 454, the system found 17 404s. Based on the math, the system has determined an acceptable amount of 404s is between 1.7 and 30. 17 is between that range, and so that's considered normal or acceptable or just fine, whatever. The next period, the range changes a little bit. It's now 1.9 to 30. Using the math, the range has started to tighten up, and so the math is starting to apply. If we fast forward a little bit here, let me see. I'm actually gonna, let me see. I'm gonna modify one value in there. You can change this to a 3. From a 3 to a 2. I'll explain why, but it will help with my example here. So as I was showing, we have our ranges. Well, what we see here is the value is 16. The range is 8.6 to 26. That's within that range. That's good, acceptable, normal. Now, the next time period, the range is 8.8 to 26, so still about the same exact range, but the value is 7. That is outside that range. And so what the system is letting us know here is that we are outside that range, that a violation has occurred. Now, looking at this data from this view is not very good. It might be. I mean, some of us kind of can view this data perfectly fine, but we want a more visual element. And so what I want to do is I want to use the line chart here. And what the line chart is going to show me is the outlier taking place. The blue line here, this dark blue line I see, is the error count. So it's showing for each 1 minute period how many error counts we had. This light blue cloud is representing the upper and lower limits of the outlier based on the math. And then these pink triangles are representing those outliers. These were the points where the values were outside the range. And so what we see is over the past 60 minutes, we had 3 periods of time where the system had a different amount of 404s than it was expecting. Now let's talk about that math a little bit. The direction. The direction is going to allow us to modify the outlier to look above or below or both for the outliers of this cloud. Now, these bottom ones here, for example, do I care that I had less 404 errors than were expected? I might, but typically I want to know about more 404s, not less. So I could say, you know what, don't show me plus and minus, just show me plus. Now I see this one bad point. Using the math, I can start to modify the calculation. Threshold is essentially standard deviation. It's a little more complicated. The documentation goes into it, but essentially it's standard deviation. And by modifying this value, I modify the range that's being used to calculate. So if I change this from a 2 to a 3, I go from having one bad point. Actually, 4 even. Actually, I'm going the wrong way. If I do a threshold of 1, sorry, I have, what, 7 or 8 bad points. If I do a threshold of 2, I have only 1 bad point. So the threshold is allowing us to determine that standard deviation, that bell curve, and adjust it as appropriate. And what you're going to want to do in the real world is modify or play with these values to set them the way you want. Are you being alerted too frequently? Maybe change the threshold. Are you not being alerted frequently enough? Start to change these values and essentially have the system hone in on when things are not quite right. And what you can then do to take it even a step further is then start to be alerted. What we can do, and we're going to kind of do a modification of this as a lab in just a few moments, is create an alert that says the next time we have more 404s than we're expected, we get notified. And then we can go ahead and go from there. So let's see, question about statistical frequency. Wow, you're really getting mathy on me. Let me point you to the help because it gets quite mathy, like I said. So let's see. Yeah, so there's all kinds of different just things in here. So I'm not quite exactly sure, Thomas, but let's see to see if it's a normal distribution. Oh, so that's where the threshold would come in, setting it as the default. Yeah, so here's what we have. I don't think, yeah, we're not going to, what you can do, we can do, just not exactly through here. All right. Cool. So I think we're good with that. Once again, I apologize for the acceleration on the lab, but wanted to certainly show this. This is one of the better, they're all great features in Sumo, but this outlier is a really helpful feature because it starts to let the system decide what's normal. Now you could say, well, why don't I just want to decide what's normal? I can go ahead and create a rule that says, why don't I just create a rule that says if there's more than 30 error counts to send me an email? And you can, very easy to have the system generate on a static number like that or static value. But this allows the data to be dynamic, because if you grow 10x in a month, you might be concerned about 300 static error counts, not 20. And so dynamically that outlier is going to grow with you, versus if you use the static number, you would have to go in and change that periodically, which would not be effective. So the outlier allows for that dynamic capability to take place, which is really great. So really cool feature, really helpful. But yeah, if you really take away one operator today, I don't know if outlier is the number one I would take, but it's a pretty important one. All right, lab 11. This is it's very straightforward, as you might predict, because it's the predict operator. What it's going to allow us to do is do future trends. So I'm going to grab the query. The first 3 lines are the same query we've been doing all day. So you kind of know what we're going to see here, but let's do this real fast. So once again, the first 3 lines, we're looking at our status code of 404s. We're looking at the error counts. We're time slicing those. And then once again, we have those error counts. Now, what if we want to not look at the past, but look at the future and start to do some prediction modeling? Well, that's what the predict operator allows us to do. And so now what we see is the system looking at the previous results, starting to do some modeling. And when we put it on a line chart, now we see that model occur. And so we start to see that it looks like we're expecting an increase in 404s. This might be concerning. Maybe we need to stand up a new server. Maybe we need to reboot it or get more bandwidth or whatever. But the system is letting us know, hey, this is skewing upwards. The prediction modeling also has a lot of math. This gets very mathy. We have an autoregressive model, a linear regression model. Yeah, I'll refer you to the help for it. It's really good. And this actually might do the normal distribution that you were looking for, Thomas. It might not as well, but might want to look in here. All right, so prediction is cool because imagine this on, like I said, a big screen. You see it skewing upwards or downwards. And you could take appropriate actions. Let's see. All right. Lab 12. Lab 12 I'm going to skip over. Oh, the question was how to show prediction with a bar chart. Well, that's how to show it. I guess it's effective. It's a bar chart. It's showing skewing upwards. We also could start to kind of play around with these as well. So we could start to mix and match there. A little bit of a segue, but good question. Okay, so where were we? I'm sorry. We were on lab 12. This lab, I don't like, but I want to show it to you nonetheless, because the feature, the operator is good. The lab is not. It's actually picky. Sometimes it works well, but let's take a look at this kind of quickly. Not too quickly, but sort of quickly. This is a transaction operator, and there's some operators that are very similar to this, where we cover those in other classes. But the transaction operator allows us, or allows the system, to look at a unique transaction identifier, an IP address, a session ID, whatever it might be, and group messages together based on various states, and we can define these states. So imagine we have an e-commerce website, and users come to the website. The various states would be process when they go to place an order. They might get to the state of putting their billing info in. They might get to the state of putting their shipping info. They might get to the confirmation state. They might get their order shipped. That would be a state. So these various states. And what we can do and what we're going to do is have the system create a flow diagram. Now, let's see if it works. Like I said, it's kind of picky. So I'm just going to copy the query. I'm going to do a log search. I'm going to do the last 24 hours. And I'm going to paste all this in. And I just want to see what comes out. And then I'll kind of go backwards and explain it. All right, it's actually working okay. So what we're doing here, and it's a little messy, but it's okay. What we're doing here is we have our log messages. And for each log message, we have an IP address, which we're going to use as our unique identifier. And then we have a status. So what we're doing here is we're saying, take the IP address, and this is another way to do IP address. We didn't show this regex, but it's the same thing. Transact on that IP and group or create these various states. So if you have the string of order, let's see, order shipped, create a state called order shipped. And then what we're going to do is we're going to show the results by flow. Oh, that should be table view. And so what we're now starting to see is here's the IP address. Here's the state that it went from and went to and how long it took to get to each state. Now, what we can do is we can count these. And ultimately what we can do is put them in a flow, or as it's called, a Sankey diagram. Now this one is really messy. That's why the image here is a lot more pleasant. But what this allows us to start to see is where people were getting hung up. What I can start to see is this many people got to the cart step. This many people got to the order ship step. This many people got to the confirmation step. Why didn't all these people get from this step to another step? Now, I can't necessarily tell you why people did not get to the shipping info if they got to the cart step, but we can start to see that people were dropping off. And so what we can then deduce or start to figure out is why are they dropping off? So this can start to show us that they are reaching these various stages or not. And then we can start to dig deeper and try to figure out why are they not reaching that stage? Is there an issue with the website? Is there an issue with the certificate for the website? People not able to get to the cart page because the icon is too small. We don't really know that, but we can start to tell you that this is the behavior we are seeing. And so, or that you are seeing in your environment. And so that's what this does. So like I said, this example is not the best, but this transaction operator is pretty helpful. And there's a few different versions of it. There's a merge, there's a transaction eyes. We covered them in one of our advanced classes. So for right now, that explanation was good enough that you can group things together based on states or groupings. All right. All right, one more. I think we're down to lab 13. Lab 13 is a great way to end today because it takes everything we've done already and sticks it in the lab. What we want to do is we want to create a meaningful alert. In this lab, rather than alerting on a simple count, and a simple count would be alert when I have 100 404s or a static number, we want to have the system create an alert when some variables are happening. When our 404s are increasing at a higher rate than our 200s. So we want to look at 404s, we want to look at 200s, we want to see success, and we want to alert really more when there's fails or issues. So how do we do that? Well, here's the query. And like I said, we've seen all this already, we're going to run through it again. So I'm going to do a new log search. I'm going to paste this in. I'm going to go line by line, but you should know what these do already. So in the first line, I'm looking at my Apache Access data, and I'm using the status code filter, the field extraction rule. And I'm saying only show me status codes that have a 200 or 404. If it's status code of 503, I don't care about it for this exercise. And so as a result, I should only get 200s and 404s. And I can confirm that by looking at my field browser. I'm going to use my time slice. I want to look at this data granularly. I want to see how many error codes I had at 5 o'clock, 5:03, 5:10, 5:15. I want to look at periods of time. I want to use this tally system that I used earlier, the successes and fails. I think earlier we called it client errors, but it's the same idea. When I run this, the system is going to look at the log message. The log message is going to either have a 200 or a 404. So for every log message, we're either going to have a fail 1, success 0, or success 1, fail 0, one or the other. Now what I'm going to do is start to do some math. I'm going to say take the successes and add them up. Take the fails and add them up and do it by time slice. My goal here to compare apples to apples. How many successes do we have? How many fails we have? And so now I'm starting to see at 519, we had 326 successes, 15 fails. 548, we had 388 successes, 13 fails. Which is better? One is better than the other. How do we get really apples to apples? That's what I'm doing on this line is I'm creating a failure rate percentage. Saying take the fail count, divide it by the success count plus the fail count, multiply it by 100 and give me a failure rate percentage. And now I can start to say, here the failure rate percentage was, wait for it to load. Here the failure rate percentage was 4.3. Here was 3.2. One is better than the other. And now I can start to compare apples to apples. Now I want the system to compare those apples for me. That's what I'm doing here with the outlier. What I'm saying is take the failure rate percentage and perform the outlier and all the math against it. And now when I run this, I get this view, but this view is not really pleasing. I can go ahead and click on the line chart. And now what I see is over the past 60 minutes, there have been 4 periods of time where we had a bad ratio. These are concerning to me. And that's great. Good to see. Perfect lab. Well done. But we haven't completed the lab. At this point, we now see in the past 4 periods of time. But the goal of this lab was to create a meaningful alert. This stuff happened in the past. That's not meaningful to me anymore. But alert in the future, when it happens next, is what I want. And so how do I create an alert from where we're at right now? Pretty simple. What I'm going to do is add one line, which is actually going to serve 2 purposes. I'm going to go back to my table view just to show this line. But the line that I'm adding, it says, show me where failure rate percentage violation is greater than 0. Basically, only show me the failure rate percentages. So now when I click start, I am only going to see those 4 bad points. That's good. I see those 4 bad points, but that doesn't help me in the future. What I want to do now is I want to go ahead and save this. So what I'm going to do here, or what I can do here, is I'm going to go ahead and save as. Give this the name. The name here is fine. What I'm going to do is specify to schedule this search. And now I can decide how frequently do I want this search to run. Every 15 minutes or real time. Real time is what I want to choose, because what's going to happen now is the next time this query runs and there's a result, meaning there's an outlier, the system is going to email me. Or you know what? I don't want it to email me. It should email the operation team. Let them figure out why we're getting so many outlier of the 404s. Maybe they need to add more bandwidth or whatever they need to do. And so this is a great way, one, to finish up the lab in today, but to maybe a bit ironically, the power of Sumo and actually keeping you out of Sumo. So you can create this alert. And so the next time you get an alert, you had more 404s than were expected, and then you go to that playbook. You don't have to sit in the Sumo creating a query, having it run every 5 minutes. It's going to do this automatically for you. So want to wrap it up with this lab because, like I said, it's a good way to show everything we did and show a good way to utilize these queries in more than just doing a search. All right, so I'm going to pause here. Questions we've been doing, but certainly if there are any specific, of course, throw them in. But let's go ahead. Let's kind of wrap things up. Let's talk about the exam next. I'm going to go back to my deck here. questions. So kind of doing that, but let's talk about the assessment. So what we're about to do is we're about to take a Sumo Logic exam. You may have taken one before, you may have not. If you have, you kind of know where I'm going with this. If you haven't, I'll go through these steps slowly. So first thing we want to do for taking the exam is we want to make sure that we log in as ourselves. We don't want to take the exam as training analyst or training user, whatever. We want to take the exam as Bob and Bill and Jennifer. So make sure that you're logged in with your corporate or professional or personal Sumo account. And I'm going to assume everyone has one here. If you don't, let me know. But like I said, I assume you do. So you'll log in with that account. Once you've logged in, and I'll go through these steps a couple times, you should be on the home page because that's where you just should be brought to. And then you're going to want to click on certification. Once you click on certification, you're going to want to click on get certified. This should take you into the certification portal that you're about to see. If it doesn't, let me know and I'll show you how to get around it. It's a little issue, but we have a kind of a hack for it. Not a hack, a fix. Once you're in here, you're now in our training portal. You can go ahead and view some of the live trainings that we've done previously, but what we're going to do today is get certified. So you'll click on get certified. And now you'll select the exam you want to take. We want to do Search Mastery exam today. You can also use the nav on the left-hand side of the screen to look for the exam. We have it in multiple languages. If you want to take a foreign language, feel free to. Might not be a foreign language for you. Pick the language that's appropriate. So I'm going to choose the English one, Search Mastery exam. When I select it, I do have to register. There's no fee at all. So registration is free for you, free for your organization. And then I'm going to click start. It's going to go ahead and give me just some guidelines, and I'll talk about these guidelines in a moment. And then we'll have our exam in a second or two. We'll take the exam, or you'll take it. And then you'll click next. You'll then get your result. Hopefully you did better than I did. Once you get your result, it's important that you click submit. If you don't click submit, you won't get credit for the exam. It's weird behavior. It's not Sumo behavior. It's exam behavior, but that is the system. So make sure you do click submit. I will remind you, I'll keep this up, is the promotion for the Uber Eats. So I'll leave this up later. I'm going to go to another slide, but as a reminder, please take advantage of this. And now I want to go over, where is it? This thing. So for this exam, it's going to consist of 30 questions. You're going to have 60 minutes to take it. The clock starts when you take the exam. So you're not going to need that much time. You'll be done before 60 minutes, but you do have that much time allocated to you. You need a 75 to pass, and it is an open resource exam, like many of our exams are. Open book, open Google, open Sumo, open documentation. You have access to these resources in the real world. I think you should have them when you're taking this exam. So feel free to utilize those resources. Use the operator cheat sheet and all those things that we've been pointing to. And I'll tell you, in case you don't know, all the answers for the exam can be found in the documentation, and that's intentional. It's not just a hack around. It's we want you to get comfortable with that data, with those documentation. So let's go ahead and start the exam. Once you're done, you're free to leave. Of course, you don't have to sit around. If you have any questions while you're taking the exam, let me know. I'll put myself on mute. Odell will be here as well. We'll kind of hang out for a little bit. But best of luck on the exam. And certainly, if there's any questions, let me know about getting to the exam. Let's see. How do you email a query? Good question. Unrelated. Good question. So let's take a look. So there's a couple ways to do it. One is you can always just Control-C and copy it into an email. And send it via email. Kind of joking, kind of not. That's certainly a way to send a query. But the way we're going to encourage you to utilize is this share option. So what I can do is I can go to share, and now I can choose to share this query with somebody. And I can give them this URL. And then they automatically will get that query. All right, well, it'll pop up in a second. There we go. Or come on, there we go. There we go. So that's probably the best, well, not the best way, it is the best way, is to share and then copy. You can also do the code segment as well, which is kind of cool. So you can do new. And the good thing about this is it retains all the information of the query. It's not just the query, it's the time, any filters, things like that. Okay, so that's that question. Which exam are we taking? Good. I'm sorry, I shouldn't have laughed. Good question. We are doing the Search Mastery exam. So it should show up on the top pane. Show you. It's this guy kind of. Here, the Search Mastery exam. Let's see. Can there be multiple recipients while creating an alert? Absolutely. So I didn't show that, but it's probably easier than you thought. So when we do a save as, or when we schedule this search, we're just going to use commas. So Josh at Sumo, Bob at Sumo, et cetera, et cetera. Just commas in there, really easy. Let's see. Do I need to? And then as a reminder, you're going to want to send that cert in to this address. All right, so that's going to conclude me talking. Certainly, if there's questions, of course, throw them in the chat, and I'll jump in if anything comes up. But let's go ahead. Let's start the exam or continue the exam. Certainly, wish you best of luck on the exam. Please send it in to us. As it says on the screen, and Odell put that email address in the chat as well. And yeah, thanks again for attending. I hope to see you maybe tomorrow, certainly another class. So best of luck. Let's see a couple of just not little questions, but last minute questions. The recording will be sent out. So we'll send a recording out to you. Should come out tomorrow, midday-ish or so. And then for the exam, let me just show one more time because there was a question about getting into that. And certainly if you want to ignore me or even hang up, you're welcome to. But let me just show this. So with the exam, to get into it, you're going to go to service.sumologic.com and log in with your account. So I'm hoping you have a Sumo account, and then that's when you'll go into certification and do that. So the URL, I can't really share the URL. I mean, I kind of can, but it should be a unique URL for each user. Now, let me send it. I'll paste this URL. If it gets you to where you need to get to, it saves you a step, all the better for you. So cool. So thank you again. Best of luck, and we'll talk soon.